Okay, might as well get going. Thanks everyone for coming today. Hope everyone's having a great time at the conference and that you've learned a lot and met some interesting folks. My name's Rich Lander. I'm a member of the .NET team at Microsoft. I've been on the team for many years and shipped a lot of .NET products, some of which you maybe have used. Yeah, so today we're going to talk about .NET for any device. It's actually one of the things that's most exciting about the platform, which is just it's expanding in terms of its utility, in terms of where you can use it, and that's great. So I wanted to start a little bit about why people pick .NET and C# in the first place. So traditionally, it was because it was best on Windows, meaning it was really the best option for a lot of people on Windows. A lot of people were using Windows. And then it's really productive. It's really easy to reason about. The garbage collection helps with that. And C# is a straightforward language. That's kind of that's how I think about the platform from kind of a bit more of a backward-looking standpoint. These two things are still very much true. Looking forward, developers pick .NET because it's a great cross-platform solution. If your boss comes to you and says, we need this app built, say for iOS or Android, there are a lot of solutions out there. So we want it to be the case that you pick C# and .NET to do that. It could be because you really want to remain productive. It could be because you have a lot of .NET code that you've built up in your business that implements your business logic, whatever that choice may be. But these are kind of the reasons why people pick this platform. One thing that people might not realize is .NET has actually always been cross-platform. It isn't something that's just come about recently. So this is some IL this is some IL code. So most of you aren't familiar at looking at this. So when you take your C# or your VB or your F# and you compile it, and you create a .dll file, this is effectively what's being created. Now this is a textual form of IL as opposed to the binary form that's in .dll files. But this is actually what's being created. And if you look at this, you can kind of see that there's nothing in there, like you won't necessarily understand every line per se, but there's nothing in there that's chip dependent or operating system dependent. When this platform was built 15, almost 20 years ago, one of the major goals was that it didn't have any affinity to any one chip or operating system. And that has actually ended up being tremendously useful. It's probably one of the very best decisions that was made. So that was more of the technical aspect. And now this is kind of the proof that it's true. So these are just a selection of the releases that we've done over 15 years. So the main thing I want to point out is that there have been a lot of releases done that have targeted multiple operating systems and multiple chips. And so we're just continuing to be on that trajectory, and we expect that to expand and continue. And this is by no means the complete set. So that all kind of comes down to just the sheer adaptability of .NET. So I just kind of have drawn some examples. So on the bottom left, we have ARM and Intel. Those are kind of the two major chip platforms in the world today. It's kind of Intel on desktops and servers and ARM on phones, although it turns out they're both actually trying to encroach on each other's space. And so .NET works great in both places. As a .NET developer, you don't have to care at all about these chips. You just write the code you want. And even though actually there are some incredibly important differences between those chips, we hide that all from you. This one's kind of near and dear to my heart, working on the .NET team. So we have kind of two modes of running your code. So most people who've run .NET apps use this kind of JIT mode, if you will. So that's just-in-time compilation. You compile your code into these .dll files, as I said before. That's not the compilation I'm talking about. And then those DLL files, they're not actually naturally executable by the chip. They have to be just-in-time compiled to machine code. And so that's that kind of one model. And then in another model is you actually pre-compile the code to machine code ahead of time. And that's actually, say, for example, how Xamarin apps work on iOS. They're pre-compiled so that by the time they get to the customer machine, their machine code, there's no compilation that needs to be done, and they're ready to go. So .NET's adaptable in this way, too. There's different ways that it can be executed, and the code does the same thing, and it's all good. And last, this one's kind of obvious. We're on a whole host of operating systems. I mean, these are kind of the three main operating systems in the world. I'm kind of putting Android into the Linux bucket, and .NET works great on all three. Okay. So the thing I want you to take away, to walk away with, is just that you can write your next app in .NET, really no matter what kind of app it is. So what we're going to do for the remainder of the presentation is I just want to tell you about some of the different options you have for .NET, some of which you're probably aware of and some maybe not, and then show you a couple demos demonstrating that. Naturally, we won't be able to demo everything I'm going to talk about, but we'll cover some key points. So one of my favorites is mobile. I think everyone here understands that mobile is huge. It's iOS and Android. Those are the two big mobile operating systems. Xamarin is our solution there. For those of you who have been following closely, you'll know that Microsoft actually acquired Xamarin earlier this year, I think in April, which is super exciting. I've actually been one of the people that has worked closely with Xamarin over like the last 5 or 6 years, so I'm super familiar with those folks. They build a great product. It has incredible synergies to, it's super useful to basically a lot of .NET developers. One of the things that I would constantly hear from people is, I love the idea of Xamarin. There's only 2 things that are stopping me from using it. One is I'm not going to bet my business on a startup, and the second one is it's too damn expensive. So with the acquisition, both of those have been solved. Xamarin actually comes, it's included in Visual Studio. It even comes in Visual Studio Community. So there's really no reason not to use it. It works great. Okay. Here's just some examples of some apps, some apps that people have built with this product. So you've got obviously the phones and tablets, but so I guess backing up, Xamarin pretty much targets the Apple and the Google ecosystems, if that's not obvious. And so as those folks, build a new type of watch or, a TV part or something that goes in the car, then the Xamarin folks make sure that their customers can then go write C# code for that thing. And so, that's why you basically see the watches there. That's just an example of that. So, and they really do a great job. Usually they have the API bindings available on the same day that Apple or Google ship the native SDKs. And so as a C# developer, you're kind of never left in the lurch. You're not waiting for months. It's available right away, and you can just go code. You can go, watch WWDC if you're really excited about the Apple ecosystem, and then that same day, you can start coding with Xamarin, building those apps, trying out what you heard about at the conference. And I think that's a great story. By the way, I'm happy to take questions throughout the presentation. Switching completely, cloud is the other huge kind of growing ecosystem. So there are a few big operating systems here. This one's a little bit harder to kind of get your hands around. The mobile one's a lot easier. So clearly we've got Windows Server. It's a cloud operating system, ton of Windows Server in Azure, and actually in AWS as well. Red Hat, so this is Red Hat Enterprise Linux. Microsoft actually has a partnership with Red Hat. Our goal is to make sure .NET Core works really well on Red Hat, and we're doing that. And then another big operating system within the Linux world is Debian. Debian's important in several different ways. The biggest one is that most of the Docker images that you see are based on Debian. So most of the time when people talk about Docker and Linux, they're really meaning Debian. And so we put a lot of focus on that as well. And there's actually, maybe this is the next slide. There's a whole bunch of Linux distros that we support with .NET Core. I didn't really say this, but when I'm talking about cloud, now I'm really talking about .NET Core. This isn't even the complete set, but the basic point is if you want to take a bet on .NET Core for cloud development and Linux as part of your strategy, you can be successful using .NET Core because we don't just support one distro, there are several. Desktop, we all love desktop. We all use desktops every day. There's two solutions here. We have the .NET Framework from Microsoft. It comes with Windows. You can build WPF apps and Windows Forms app. I imagine you all know this. But actually, Xamarin has a Mac story as well. So you can build native Mac apps with Xamarin, and they obviously look different than the Windows ones, but you can be successful there. I mentioned those. When I'm talking about Mac apps, I mean Cocoa. That's the name of the API that Apple ships for Mac apps. I'll just quickly mention this, but some folks are actually starting to use .NET with Electron. There's no Microsoft-provided solution for this. If you go on GitHub, you can kind of find this. What Electron is it's a desktop. It's a desktop story. If you're familiar with Cordova, Cordova, maybe no one knows what that is here. Cordova is this JavaScript solution for phones. Electron's kind of similar, except it's a JavaScript solution for desktop applications. So like, for example, two apps that I use that are Electron are the Slack app is an Electron app, and Amazon Music is a Slack app. They just happen to be two apps that I use. And so some people have figured out, it's basically Node underneath the covers. And so some people have figured out how to pull .NET into those apps so you can actually have a JavaScript HTML front end and a .NET back end to the app. So that's kind of an interesting idea. We'll see where that goes. And those apps are cross-platform, whereas none of the other three on this list are. Okay, switching gears. Then we're eventually going to get to demos. Gaming. So it turns out gaming is huge. Gaming was always big-ish. Traditionally, you had the Windows PC, which remains the most popular desktop gaming platform. And you had your Xbox 360 and your PlayStation 3. And then these things came out, and gaming just blew up even further. And so turns out .NET is actually one of the most popular ways to write indie games. So here are a few companies. Unity's the big one. Monogame's kind of an open source project, and then CryEngine is another commercial venture. Unity, is that what this slide is? Yeah, so Unity supports between like 25 and 30 different platforms across these different types of form factors: mobile, console, desktop, VR, AR. They have about 50% market share. So I actually go to game conferences, and then I actually walk up to the game developers and I ask them, what framework or toolkit do you use to write your games? 90% of the time it's Unity. And so that's all C#. It's quite impressive. So we work closely with that team. This is just a random picture of a Unity game. So it's like, wow, that looks kind of immersive. Obviously, this particular part of it isn't the C# part. This is, textures and visuals and that kind of thing. But the code that actually drives the game, that does the physics, determines what the score is, determines when it is you should die, that's all written in C#. So that's kind of exciting. Okay. That was kind of the marketing part of the presentation. So let's talk a bit about app construction. This part isn't so much about how to construct each of the apps. It's more about how you share your C# code across them. So we've had a set of code sharing stories over time. You can see we're taking a while to get this one right because we have four different solutions. I can tell you at the end which one you should be using. Let's see. Probably should have ordered this a slightly different way. So traditionally, the two oldest models are linked files and PCLs. So linked files is basically this idea that you have, say, a solution, you've got 10 projects in it, I'm just making that number up, and there's some source files that you want to use in multiple of the projects, and so you basically kind of do a bunch of // to get at some of those files so that it can be shared. There traditionally was a very bad story in Visual Studio for that because you'd get you'd update the file here, and then you'd get warned. It's like, oh, this file's been updated, but it's really the same file. Some of that's improved. And then PCLs is a binary code sharing story, which is you build this project once. You don't reference any of the files from anywhere else. And then this particular asset is usable as a project-to-project reference to all your app projects. So that works pretty well. The only downside with that is the more platforms you said you wanted to share with, the smaller the set of APIs you could use. So it's like, I'm trying to be good. I'm trying to increase my breadth, but then I get punished by giving up APIs that I would like to use. Well, that's not good. So anyway, then we came up with two other solutions. Shared projects then became the replacement of linked files, and this is a Visual Studio feature that shipped like four years ago or something like that. It's this basic idea that there's a body of code in this thing called a shared project. It's kind of virtual in nature. It doesn't actually build any assets itself, and then it's just a dependency into real projects that do build assets. And so it's just a way of kind of formalizing linked files. So that's good. But I think the real solution is this one in the bottom, on your bottom right, which is net standard. I created this little acronym just because it wouldn't all fit on the text would bleed over. So it's called .NET Standard. And the basic idea here, and we'll compare and contrast it with PCLs, is it's a human-curated set of APIs. So we got feedback from people, particularly around .NET Core. They said, love the idea of what you guys are doing, making .NET available on other platforms, but man, you really don't have enough APIs there for me to be successful. It's not economic for me to move to these platforms. I'm not going to move until you give me the APIs I want. So we heard that loud and clear. And not only did we decide we're going to put more APIs into .NET Core, we realized that this was more like a pattern that we needed to just go fix once and for all. We're not the only ones now building platforms for .NET, so we just decided, let's spec out what are the minimum set of APIs that every developer should have, no matter which platform they're using, so that their code, that they can have high confidence that their code will work on this new platform from day one. So anyone think that's a good idea? So anyway, that's what we're doing. The spec has actually been published. You can go to github.com/.net/standard, .NET standard. Just in contrast to PCLs, the way PCLs worked before, and this is why you kept on losing APIs as you added platforms, it was this machine-generated intersection of the platform. So basically, as you added another platform, if it had less APIs than the other ones you were already using, by definition, the intersection would be smaller. So it behaved by design. So anyway, we're coming up with a different model. The other thing is PCLs was entirely reactive, whereas this is proactive. .NET Standard is also not singular in nature. It's a versioning spec over time. So we will add more APIs to it over time as we get feedback. OK. Yeah, this is basically just showing if you want to build these phone apps with Xamarin, this is kind of what the apps looks like. And behind it is the experience you have in Visual Studio building them. The code that you write should look very familiar. OK, I just want to say one more thing about Xamarin, which is this is kind of like a architecture sort of picture of what the apps look like. So the basic idea is at the very, or we can start at the bottom. The bulk of your app is actually this C# code that is your business logic that can be shared across all the operating systems that you decide to target. And then you actually have a choice that comes next. You can either write completely custom user interfaces for each one of the operating systems. And that's if you have an app that you really care about, that there are going to be a ton of people using, and maybe it has like really specific performance constraints, then you would probably do that. If you have an app that's taking kind of like business orders or is displaying like bus times, you probably don't need to do that. So there's actually a solution where you can write kind of against a lowest common denominator abstraction of mobile user interfaces. And so then if you code against that, then that code is shared as well. And then you actually have very small places where you poke out, where you decide, I really want to customize my app for the way the GPS works on Android, or I really want to customize my app for the way the accelerometer works on iOS or iPhone. Those are the sort of things that you do. And you can kind of mix and match these. OK, last slide, and then we get into demos. So I'd be remiss, since I work on .NET Core, to not talk about Cloud Attach. So, at Microsoft, we kind of have this what we call mobile first, cloud first. And so the idea is that mobile and cloud are very much intertwined. There's very few great mobile apps that don't have some kind of a cloud backend. And so the basic idea is you definitely have the device app in the middle. Maybe you build an ASP.NET Web API. That's basically like a REST sort of endpoint. And you call to it to get some kind of information. You've got some sort of storage. Maybe you're using something like Azure Storage. And then maybe it's the case that there's certain interactions in the app that actually have to go do work. Not sure exactly what those would be. But you can imagine that someone walking around with an app that like takes surveys from people, and then it's got to go both upload that data and crunch it in some way to start gathering meaning from that. So all of those are options. OK, let's do some demos. So I got a couple of demos here. Let's see. So I'm going to start here. So this is going to be both Windows and Mac. This is the Mac. This is Windows. So we're going to start with the Mac. And so we have this app that's a Xamarin Forms app. Might as well just start it. I'm going to show it to you on iOS. There's something super weird going on with the, it normally wouldn't quite look like this. My resolution's been changed to kind of fit this tech. Anyway, so here's my app. Yeah. Something's not also quite working correctly with the simulator. There's a part of the app that's above it that I was able to see before when the resolution was different. OK, and none of that matters. So what this app is a Xamarin Forms app, and the app is called .NET Feature Catalog. It's actually also on GitHub. We're actively working on it. It's github.com/.net/features. .NET, yeah, feature catalog. And So what it is it basically just provides you a user interface over a bunch of features. We just built these, yeah. And so one of the features of, man, yeah, no idea what's going on here. Oh, man. The one problem with this is the back button is at the top of the screen. I wonder, there must be a way to zoom this. Or maybe I can, let's see. Ah, that's what happened. Okay, now we're golden. This is what the app should look like, yeah. .NET Catalog, okay. This is what the app looks like. I'm glad we got that fixed. Yeah, so here's Xamarin, native mobile, and then it just shows you some text that describes it. It's nothing fancy. It's basically just trying to show you what one of these Xamarin Forms apps can look like. And we're not just gonna, the app itself isn't really the important part. So what I wanna show you is kind of more how it's structured. So we've got this app at the bottom. It's just called Net Catalog App. And this, so the way it's structured is you have the Xamarin Forms app. That's the bulk of your application. It's actually a portable library. And then it's actually referenced from the Android app and the iOS app and the Windows app. And so let's actually start with the iOS app. And the thing I want to show you is actually look through. We're going to want to make that. This isn't. Let's close all these. I was working on the app before. Let's go to the iOS app. This is, yeah, okay. So you may not be familiar with how iOS works, so I'm just gonna walk you through kind of where the iOS part starts and ends, and then where the Xamarin Forms part starts and ends. So this app actually looks a lot like a console app in some ways. You've got a main method, it takes string args, and basically this is where you boot up the UI application, and you're saying, the thing I want you to boot up is the app delegate. In some ways, it's actually similar to how WPF and Windows Forms apps get booted up as well. So we're gonna go to the app delegate, and this is what iOS apps look like. And then there's this one call here to load application, new net catalog, pardon me, new net catalog app. And we just booted up the Xamarin Forms application. And then there's, unless we want to, we don't have to do anything more with iOS other than that one line. So, and I'll show you what it looks like in Android, just to kind of prove the point. So in Android, things are structured in terms of activities, not super important. And we have the same line here, load application, a new catalog app, and once again, we're booting up the Xamarin Forms app, and we don't have to do anything in the Android app if we don't want to. Now, some people might wonder, it's like, oh, well, that sounds good. I can see how that would make me productive and be useful, but what you just did is you created this like weird .NET layer on top of, you know, the Android operating system and the iOS operating system. Like, how can that be good? You've like got this whole user interface layer on top of the Android and iOS user interface layer that must use like double the memory, and it probably all looks different, and that is not how it works at all. So the Xamarin Forms UI layer is actually just an abstraction. It renders down to native controls. So it renders in terms of the user interface, so it actually doesn't look the same on iOS and Android and Windows. It actually is intended to look like an iOS app on iOS, is intended to look like an Android app on Android, and it does that because it actually uses the controls. When you use a Xamarin Forms button, it's just a very small layer on top of a native button, and the cost overhead of that is extremely minimal because it's been implemented in a very efficient way. So so you still are fundamentally building a native application. Also, all of this code, you know, well, I won't go there. Let's actually look at the app. Okay, So let's look at my, my actual Xamarin Forms app. So we've got, the very first thing is an app.cs. It's basically deciding what the main page is going to be in the application. And I'm saying it's going to be this new topics page. And then we go into there. So it uses XAML. So it looks very kind of like WPF-esque. If you're used to building Microsoft user interfaces in, say, WPF or UWP, then this is going to be very familiar and straightforward. There are designers for that as well. And then you've got a code behind file that does a bunch of things. This one, this is the code, this is the code that built the user interface that we just saw. All it's doing is building a stack layout and assigning an image and a label to each one of those entries, and it's basically as simple as that. This is actually incredibly simple code. So I showed it, and then this app only actually has 3 pages. So there's actually not a heck of a lot to it, so I'm not going to walk you through each one of the files. So what I thought I would do next is let's go back over to, let's go to Windows. So part of the promise of this solution is that I shouldn't have to do twice the work to get twice the number of apps. So let's take that same app, and so I already opened it up before, unsurprisingly. It should be in my recent list. Yes, it's this one. Okay, so let's look at this. What does it look like on Windows? So let's, some aspects of this are a bit messed up because I have some solutions in here that are not loadable in this particular version of Visual Studio. You can ignore that. But we have the same model, which is we have the portable Xamarin Forms application. It has exactly the same files as the one we just looked at on Mac. In fact, I said this is a GitHub repository, so I just git cloned this particular repository to this machine and ran it. And then there's a UWP project, and let's look at how it's structured. So I believe app.xaml.cs is actually, the first file, this is way too big. Let's try 150. Okay, that's better. First file that gets loaded, blah, blah, blah. Okay, this is actually, this is a little bit too confusing. Oh, here we go. This code, I think, is a little bit different. I don't know if this is still the recommended pattern, but it says Xamarin Forms, forms.init. So that kind of gets it started. And then this must be where the main piece is. Right. And then within the main page, we have the same load application call, and then the rest of the application is effectively rendered in terms of this main page. And that's it. That's the entirety of the Windows app. And so let's run it. Right. Windows has this funny thing where you have to deploy the app first. Deploy. Okay, that succeeded. I think I'm going to have a resolution problem again on this machine. I don't actually know how to change that here. So, does any of these help? No. So, anyway, it's fundamentally the same application. Obviously. I'm just showing you basically that it works. So great. This thing lived up to its promise. So I thought what we would do for the remainder of the time is I wanted to show you how easy it is to extend this application. So I'm kind of going to extend it in a bit of a fake way. So imagine, oh yeah, one thing I didn't tell you is this application is getting its data, all that data you saw from a web service that we also wrote. It's a .NET, ASP.NET Core web service that's on Azure. This is actually the endpoint, .NET-features.azurewebsites.net. And so it's got an endpoint called topics. And then if I'm interested in .NET Core, which I definitely am, and then it returns me a list of concepts. And then the thing I care about, yeah, which feature do I really care about? Cross-platform. Yeah, I definitely like cross-platform, which I spelled wrong, so that didn't work. And then it gives me some markdown back that the app can render. So that just happens to be the way that this app is structured. So one of the things I was actually literally doing yesterday is I wasn't the one who initially built this web service, and I found that it was slow. And so yesterday I actually changed this web service to use async differently, and it is actually faster now, which is awesome. But I still don't quite trust it. So what I thought we would do is let's build a test page. So let's create a new file. We're going to do XAML, and we're going to call it test page. And I'm going to show you in about 5 minutes how we can create a new page, and we're going to run it on both iOS and Windows. OK, so I'm actually not that great a coder, so what I'm actually going to do is I'm going to copy a bunch of stuff from this categories page. I'm going to copy all of this, and I'm going to go here, because we're basically going to create a similar-ish user interface. Oops. Oh, man. I go between Mac and Windows like all day long, and I always get mixed up between copy and paste on the two operating systems because they don't use the same keys. I've been doing this for ages, and I still have a mental block there. OK, so we have to go back. Command-C instead of Control-C, and then test page. OK, weird. That's so weird. Edit. I've never seen this happen before. Copy. I can type this if I have to. OK. Let's close all tabs. Don't save. OK. I just want to try this one more time. If this doesn't work, we're going to try something different. Grid. I did actually do this before. Oh, now it's there. Super bizarre. OK, computers. OK, so the only thing I need to do here is I'm going to change the name of the grid. Topics grid. I think, yeah, we're going to call this test grid. Oh, that's right. Oh, no, wow. I'm looking at the wrong page. That's the reason. There we go. OK. Test grid. And then, now we can go a little faster. I'm going to grab this same code, because we want it to basically do the same thing from this point on. I think that's what we need. And go to my test page. And so I like to use async a lot. So the pattern that I found to use here is like using async in a constructor typically doesn't work well. just based on the non-return type in the constructor. So I actually use this on appearing method, which we can make async void. It's not overprotected, it's just protected. And so what we're going to do is we're going to call into this service, and we're going to call it 10 times in a row, and we're going to see how fast it responds. That's the whole test that I want to do and what we're going to put onto the page. So the first thing we need to do is type, let's create an HTTP client equals new HTTP client. And I don't have access to this, so we'll do a quick fix. It's not that command, it's this one. Wow. That's not what I wanted. Okay, but let's do it by hand. Oh, it is there already. I'm in the wrong place. Okay, I'm going to add it by hand using system.http.net. And that should be found now. Okay. Okay, no idea why that's not working. Okay. Oh, it's not that direction. I have used those types before, believe it or not. Thank you. There we go. It's amazing how, when you're presenting in front of an audience, how your brain kind of slows down to 50% speed. I'm sure that happens to nobody else. Okay, so now we need the URL. So I have that up here. We're just going to test the one URL. And then we are going to, for each, actually, this is where I can grab this code again. Control C, and back to my test page. Basically grab this. And so we got, and we can do this call here too, which is var topics equals client.get string async URL, and we'll await that naturally. And topics. And let's see. Yeah, so this looks good. Topics.count. Oh no, it's a string. So, oh no, yeah, we want to do something different. We want to call it, say, 10 times. And then, oh, right. And then instead, we don't need an image, so let's get rid of this. We still do need a label, and so, and I think we just need one thing. Hopefully, does this require two things? That's right, we need a stopwatch. Oh, that's right, this call needs to be within the for loop. And so we do this here, that's right. And we need a stopwatch, so let's see, var stopwatch equals new stopwatch. Hopefully it can find this. I'm definitely pressing the wrong button. So I know where that is. It's in system.diagnostics. Okay. So we want to build, okay, stopwatch. So stopwatch.restart, and then stopwatch. Stop. Yeah, if folks haven't figured out, this is a bit of a contrived scenario. And then stopwatch dot elapsed milliseconds. That's right, I don't need this. I just need, now I remember how I did this before. New label, right. And then all I need to do is label.text equals stopwatch dot elapsed milliseconds dot toString. We're almost there. And then we need a stack layout. We don't need the image, we just need the label. And we color.transparent, blah, blah, blah. Right, and then we need to put the, oh, we called this, did we call it test grid? Yeah, test grid dot children dot add, blah, blah, blah. Okay, let's see if this works. So one more thing we need to do is we need to integrate this into the application. So instead of topics page, I'm just going to change this for the moment to test page. Due to some other weirdness, the namespaces don't match. That's just a weirdness with my app. It has nothing to do with this. OK, let's see if this builds. Oh, I need a semicolon there. Somehow something got deleted. Let's just, let's see. That one is for that. I think we must be missing one. Yes. There we go. Okay. App launches, cool. So obviously the first call was kind of slow, and then it was pretty good after that. So now I'm going to try and prove to you that we have a good story here. So let's close this. I'm a big Git user. If you were at my last talk, you will have seen that. So this app, where does it live? It lives here. Git features. So git status. So we changed a bunch of stuff. Let's just do it all. So git checkout -b test for DEVintersections. Let's just add everything that we've been working on. Git commit added testing mode. And I'm going to push it. This is actually going to be on GitHub now. OK, so all that work is there. Now I'm going to go to Windows. Oops. Not too sure why this Mac thing is still there, but that doesn't matter. OK, so let's go here, features, git fetch. Sorry if you don't understand what these parts are about. This is just a way for me to shuttle code between two machines that are just connected to the public internet. Git checkout, and let's go grab this branch. Blah, 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 that's all good. And then let's go back to Visual Studio. A bunch of stuff has changed, reload solution. OK, and hopefully we can just, is it going to tell me to deploy again? Yes, I don't quite understand that. OK, go here, deploy it again. Wait a couple seconds. Launch the app. And I get the same experience. Anyone think that was cool? Yeah, so obviously a completely contrived example, but the basic idea is I was able to write mobile screens, mobile pages, share them within two different apps, and it worked the first time in both places, modulo my coding problems. OK, let's see. OK, still got a little bit of time, because it started at 11:30, yeah. Okay, so that was that part of the demo. Yeah, so I just want to show you a couple other things. That was kind of the more clienty aspect of it. Let's go back to the Mac. Yes? That's right. That's a good question. So let's just back up for a tiny bit first and talk about what that would mean to start with to convert from PCL to .NET Standard. So we're actually still working on the tooling part of it, but what it's intended to mean is all you should have to do is change your target. So instead of targeting a particular PCL profile, if you're familiar with PCL and you've actually ever looked underneath the covers at what's written in the CS_proj file, it basically just says profile 228 or something like that. There are these kind of cryptic numbers. And basically what would happen is you will instead target, say, .NET Standard 1.2, depending on which is the correct one for you. And so you shouldn't have to mutate your code at all. It should just be a CS_proj targeting gesture and concern. .NET Standard is backwards compatible with PCL, so we haven't removed APIs that PCL had. In fact, when I mentioned that .NET Standard is considered a min-bar for platforms going forward, what PCL already exposed was a major input into that decision. There's tons of folks who have built PCLs either for their own use or that are on NuGet. And so it's super important that those continue to work on platforms that are kind of .NET Standard oriented. So we're still working on the tooling in Visual Studio and Xamarin Studio in terms of exactly which buttons you'll press, but you should think of it as a CS_proj, MS-build type concern and not affecting your C# code or your .NET calls or anything like that. Oh, so hopefully not. No, we do intend to do better than that, which is that there'll be gestures in Visual Studio to do that. But certainly, we've already published examples of what .NET Standard CS_projes will look like. Okay, well, so here's the weirdness. They are and are not at the same time. Yeah, if you've been following our blog, then you would have picked up on this. But basically, yeah, when we shipped .NET Core, we shipped .NET Standard 1.x at the same time. And we shipped like 5 versions on the same day. So we actually kind of backdated it, if you will. So .NET Standard 1.0 supports .NET 4.5. So we kind of had it represent the past as well as the future. And to a large degree, that's what makes PCLs possible to work. It also means that people can move to .NET Standard earlier than they otherwise would, because it's not like, oh, well, my customers aren't yet on .NET Framework 4.6.2 and .NET Core. We didn't want to get into that whole conversation, which is why it goes into the past. The existing .NET Standard actually uses this project.json format and the .NET Core build system. And so it doesn't use CS_proj. So it's a bit of a leap today between PCLs and .NET Standard. Next year, in the first half, that's when we're planning to ship .NET Standard 2.0. .NET Standard 2.0 is the place where this min set of APIs will be implemented. .NET Standard 1.x is still on the small side. And when we ship .NET Standard 2.0, we will transition from the project.json format to CS_proj. So it'll be a lot more similar to the PCLs that exist today. And the gap that you have to jump in order to go between the two will be very minimal. like I said, hopefully it's just a bunch of buttons that you have to press in Visual Studio, and that's it. Yeah. This has been a very important set of decisions, and it's been a bit difficult for us to kind of come to the right place, which is why this story is a little bit complicated. We're not super happy about these different jumps between API sets and different project systems, but that's just where we ended up. Yeah, so with any other questions before I show something else? Okay. So I thought, I think we kind of described the client side pretty well. So I thought I would show you a little bit of the server side as well. So what I'm going to do for starters, actually, let's go back to Windows for this. So let's close this app, close solution. I'm going to show you the server-side component of that app. And I'm going to show you a couple different ways. And you can kind of see that we're enabling, okay, web. And this is all on GitHub. That's right. I can't show you this in Visual Studio. Oh, but I can show you it in other version of Visual Studio. VS 2015, that's right. That's where I was using it before. Yeah, .NET Core projects are not supported yet in VS 15. Okay, recent projects. Should be this one. Yep. Okay. Okay, so what I want to show you here is, yeah, we're really suffering for screen real estate here. Okay. What I just want to show you is just a couple of things. So here's the program.cs for this application. This is kind of the way ASP.NET Core works, because this is an ASP.NET Core application. I'm not going to explain everything. I'm just going to give you a little bit of a tour. The way it works is it's what we kind of call a pay-for-play model, which is that these are all components that this particular application has opted into. With the old ASP.NET, there were a whole bunch of decisions that were made for you up front. You bought into a very significant page pipeline that even actually web services had to opt into as well. And so that used a bunch of memory and took a bunch of time. And so with this model, the dots here, this kind of fluent type format, it allows you to just opt into the particular web server services that are important for your application, and you can, yeah, and so that works. And then my application is all it is a set of controllers, and so there's routing. This is the way I say that this particular controller, it should respond to requests for topics. And you can see further down, got the same thing for categories, that kind of thing. And then concepts/categories. So it's basically a way of describing routing for the web API. That's basically just describing this thing. So this was topics. And then this is, yeah, this is categories. And then this is the concepts. That's all that is. And I'll just show you a couple other things. No, I already showed you that. Here's the project.json. Once again, I'm really sorry that we're so compressed here. So this is a JSON file project format. Really, it just describes a few things. The main thing it describes is your dependencies. These are all NuGet dependencies. And then it also describes which framework that this particular application is targeting. So this particular application targets .NET Core App 1.0, which is .NET Core 1.0. So this is what we shipped when we shipped .NET Core in June. I think that's when we shipped it. This is the technology that we shipped. So I'm just going to run this. And you'll see that it's going to start up IIS, loads the app in the browser, and we're doing the same thing. So same experience, and I can develop my application. Oops. Naturally, I can set, oh man. I can set breakpoints. Let's set one right here. Oh, man. I have no idea why that's there. OK. So if I type WinRT here, I think it'll stop that breakpoint. Yeah, so that all works. So that's this application. Like I said, so the way that this gets to the web server it's on GitHub, like I said, and then it uses continuous integration to go between GitHub and an Azure website. So every time I check in to that repository, there's a new build done on Azure, and then that's how it gets hosted there. So it's really quite convenient. I love building applications that way. So what I want to show you, though, is something different. The experience I just showed you is one that's probably more familiar to how you've built .NET applications on Windows. So I want to show you what we're doing with Docker. So I'm going to go into the same directory as we were just in on Windows. By the way, Windows has Docker support as well. I just can't actually show it to you on Windows because I'm running Windows in parallels. Docker uses Hyper-V, and so I need to be running Windows bare metal in order to use the Docker features. For those of you, let's see, let's make this big. For those of you who aren't familiar with Docker, I'll just give the 1-minute spiel on it. It basically offers a couple things. One is it enables you to have consistent software environments. The basic idea is you package up the application and all of its dependencies, including the operating system, which is huge. It means that when I take this application from development to staging to production, that application is unchanged. There was no accidental global state that the developer had on his or her machine that they were kind of depending on during development. There was no last little turd that the last test left behind on the staging server. And there was kind of no weird interaction between one app and another app in production because I have a completely closed environment all the way down to the operating system. So that's amazing. And then the other thing it does is these images are actually built in layers. And so if you have application A and application B, and they use the same operating system, and they actually rely on the same .NET Core version, those pieces are actually transparently shared in memory. And it's always correct because those layers, they have identifiers to them. They're basically hashes to know that they're the same, so it's completely correct and fine to share them. So we actually get some memory benefits as well. And then they're also easy to deploy. So let's take a quick look. I'll show you what this Docker file looks like. Oh, not type. Cat. Let's look at this Docker file. So this is what a Docker file looks like. It's actually incredibly short. What this is saying, oops, what this is saying is the first line says, this is a little bit of a stretch, but it's basically what is the operating system and dev platform that I want to use for this application? So it's saying, I want to use the .NET Core runtime. You can't see this here, but then there's another file, kind of, that image has, and it says, I want to use Debian, because this is actually a Linux image. So you've made the choice for this particular one to use Debian and .NET Core. And then it says, within the image, I want my working directory to be app. I want you to copy everything from the local out directory into that working directory. And then here's the entry point I want you to use. Some cruft got added there. And that's the entirety of the recipe for Docker. So I'm going to show you this a couple different ways. So the first thing I'm going to do is I'm actually going to run the application locally. So for .NET Core, we have this command called .NET. That's kind of your home base for all the commands. So we're going to type .NET run. And it says, OK, I've loaded the application for you. Go to localhost 5000. And this will fail because there is nothing there. And we have to go to the particular endpoint, and we got it. The exact same thing we saw before. Now, what I want to show you is I'm actually going to build this application for release, for real. .NET publish -c release -o out to get to that out directory. OK, we just built it. And now I'm going to type docker build -t. T means tag. It's basically its name. Call it feature catalog. And please find the Docker file in the current directory. OK, done. So we just built our Docker image. And then Docker run feature catalog, and that's it. So this is going to take a really long time to start, so you might as well go get a coffee. Actually not. So let's start the app. Oh, actually, there was, I have to go steal a command I forgot about. Oh, wow, OK. We don't need Java right now. Let me just go steal a command from somewhere. I forgot that I needed that. So this is a good way to introduce our home base on Docker Hub. That was not intended to be part of the demo. So you can go to dockerhub.com or hub.docker.com. You type in .NET, takes you to our repository. And it tells you which images we have, tells you a bunch about .NET, and it gives you samples on how to use it. And there's one command I need here that I always forget. All right, it's further down. There it is. Docker run. That is what I needed. OK. This is, so the one thing with Docker is it doesn't expose itself to your local network automatically, which is actually a good security feature. And so you have to specifically tell it which ports to open and that kind of thing. So that's what this command is saying. So, and I still need to feature catalog. OK, the app is started. So we're now running in Linux. Just to be clear, I'm on the Mac. We're now running in Linux on Debian. It turns out actually Docker for Windows supports both Windows Docker images and Linux ones as well. So you can run this exact same image on Windows. And in addition, .NET Core has Windows images. And so go back to my browser. This app now is at localhost 8000. That's the port I told it to go on. And you didn't actually see it change because it went so fast. So we're now talking to a Docker image on this machine that's running on Debian, even though this is Mac OS. And just type one more, C# REPL. So that's it. So the only thing that, the thing that I will want to do at some point is today my application in GitHub is deployed kind of just as a bundle to Azure. The thing I'd like to do next is actually describe my application in terms of a container and have it deployed to Azure as a container, and then I know exactly how it's running at all times. OK. Anyway, so that was that demo. The reason I showed you this is basically to show you what the back end to my front end mobile app looks like, and the different experiences that we have available. We have experiences that feel very familiar on Windows, in Visual Studio, feel very familiar to ASP.NET. And then we have a different set of experiences that's actually fundamentally using the same technology, but is kind of enabling you to use these bleeding edge kind of Docker-style experiences. Okay, so I think I will just show one more thing, and then I think we can close that down. This has nothing to do with my talk, but let's try this. No, I won't show this. Okay. So I just wanted to show one more thing. This is with respect to the portable libraries thing that was asked earlier. So I want to show you what .NET Standard development currently looks like for using the current .NET Core-based tools. It will, once we ship the next version of .NET Core, it'll be a little bit different than this, but the tools will be the same. Obviously, we'll have Visual Studio support. What I'm showing you is the command line experience. In the past with .NET Framework, we had command line tools, but they were never kind of designed to work together in a super good way. So that's one of the things that we've done intentionally with .NET Core is really have a family of tools that are intended to work together. Okay, so let's make a directory. We'll call it library test. And library test. Oh, okay, we'll do this quickly, and then I actually have one other thing I wanted to show you. And so what you can do is you can type .NET new -tlib. Is that what it is? Let's see. Yes, I guessed correctly. All that's saying is I want a template for libraries. And so if we type cat library.cs, you can see this is a library for a library, and then cat project.json. It's a similar project.json format. And then I can, this is the same format I showed you earlier, except it's targeting .NET Standard instead of .NET Core. This one happens to be targeting version 1.6, which is the latest version. And then I can actually build this application. Oh, I forgot to restore. You have to restore your dependencies first, and then you build the library. And then if you want a NuGet package, you can .NET Pack. And in no time at all, I created a NuGet package for that library in like 1 minute, less than that. So yeah, this tooling is entirely oriented around quick building of assets. And since NuGet is an important part of our ecosystem, the NuGet, building NuGet packages is built in. That's actually something we've never had good support for, either at the command line or in Visual Studio. It's always been this manual task where you had to edit these, can't remember what they're called, these files by hand. And it was kind of tedious, and there was kind of no error detection. So I've really moved the state of the art a long way forward. Okay, I just wanted to show you one more app, and then we'll pretty much be out of time. Let's see. So I want to show you back to the feature sample again. We actually built a console app as well. So console is an important part of the platform that we built. Actually, everything's a console app. ASP.NET Core apps are actually console apps. And so we built this little app, that's .NET Run It. And so it is actually a kind of REPL style experience for that same web service. And so you can we'll type languages this time. We have 3 of them. I type C#, and tells you about C#. You can go back here. So this is the exact same experience. And it's talking to that exact same web service on Azure. And so the point here is that all of these systems work really well together, and you can build different types of applications. Okay. Any questions? So I've showed you mobile applications. I've shown you cloud applications, including using them with Docker. And I've shown you console applications all working together. If there's no questions, then I'll just show you one more thing, which is people were asking about .NET Standard. So I'll show you this table that this is the table that you want to see. So it shows you, for each .NET Standard version, which platforms support it. So for example, with .NET Core, just to help explain this, 1.0 of .NET Core supports .NET Standard 1.6, which also means it supports everything that came before it. .NET Framework 4.5 supports 1.1, which means that you can use 1.0 and 1.1 libraries with it, but not 1.2 or later. And then Mono, they support everything. Universal Windows Platform Apps, 10.0, which is the Windows 10 version. It supports .NET Standard 1.4. And then the original version of Windows Store, the one that shipped with Windows 8 and Windows 8.1, is basically 1.2 and 1.3. And Windows Phone is basically the main thing. That's at 1.0. So if you want to support Windows Phone Silverlight, then you would have to make sure to target 1.0. So this is basically the map, if you will, for knowing what to choose. And so the basic plan is, as we move forward, we'll bring .NET Framework along, we'll bring .NET Core along, we'll bring Xamarin along. The Unity folks will also bring their stuff along, and we'll work together in a public process to figure out which new APIs to add. Okay. I think that's about everything I was wanting to show today. Hopefully some of that was exciting to you. And great. Thank you very much.